well, what a stack. It's a real pleasure to be here. I hope you're all energized. I hope you had some coffees, and I hope you are ready to talk about SolidStart, because I'm really excited for this talk. And sorry if I look a bit distant right now. I'm still processing how good Attila's talk was. Like, that was the best Signals talk I've seen to date. It's not because I'm biased. It was really, really good. So if you were not here for the last talk, like when the recordings show up, I assume there's going to be recordings, please check it out because it was really good. So I want to start this talk with one question. Actually, 3 questions. Let's do 3 questions. The first one, who here has heard about Solid? Okay, cool. Who here has used Solid? Okay, there's like 3, 4 hands there. And who here has watched Dune? You know, like, what the heck is this dude just said? Well, it's because 6 years ago, SolidJS showed everyone the way. Very similar to what happened in Dune. Let's hope there's not a villain arc in our story, but 6 years ago, SolidJS showed everyone the path. And this was the path of fine-grained reactivity. Attila spoke about this a bit briefly, but I'll go over this part as well to give some context. And also, this slide, I stole it from him, so thanks, Attila. We started here 6 years ago. When Solid picked up Signals and started doing its twist on it, that's where we were. We were the only ones doing fine-grained reactivity, while everyone was there on the coarse-grained reactivity way. Now, you might be wondering, what's the difference? So when you have fine-grained reactive systems, like Attila also explained before, it's systems enabled by this primitive, which is Signals, that allows you to basically not have to run any code to check if there are updates to your UI. Signals just enable to do that. When you have a coarse-grained reactive system, basically the framework has to run code to check, oh, look, there's updates. And that's basically where we were 6 years ago. Now, that's how we started. 6 years have passed. This is where we are. Almost everyone saw the value of Signals. Almost. There's still some outliers there, even though some say they do fine-grained reactivity, but that doesn't matter for here. And if you watched Attila's talk earlier, you'll understand why. But that's where we are now. Everyone saw the value of Signals. So we can, in a way, say that Solid opened the way for everyone to see how good Signals were and bringing this to our users. Because we benefited from it, from the basic and the helpful mental model that we got, but our users also benefited from it, from the performance optimizations that it brought to our applications. Now, while this was happening, around 2021, let's say, at least as my mind reminds it, there was a discussion that started showing up in the JavaScript ecosystem. Now everyone was talking about one thing, server-side rendering. Because so far we had been entered the era of single-page applications, everyone had a single-page application, but everyone started thinking, oh, maybe we want to start moving stuff to the server again. And then someone said, oh, PHP was doing that. Yes, exactly. This is the loop we're stuck in. We're bringing concepts that we used before, and we're doing it with a better developer experience. But yes, people started talking about SSR. Now, there were a couple of ways of doing SSR. Personally, I hated configuring Webpack. It was terrible for me, I didn't like it. So one of the easiest ways we could get SSR in our applications was by writing the meta framework sandworms. Because meta frameworks, it's not just about the developer experience and the stuff that brings it. Usually, and most of them have multiple rendering modes, and SSR was one of them. So the ones we see here, we have Next from Vue, we have Analog from Angular, we have Next.js from React, and frameworks were riding the meta framework sandworm. Because, well, people started seeing that there was an actual benefit to it. Now, the question that started showing up to people's minds during this time was, what about Solid? What's Solid Sandworm? Everyone has a meta framework. Why doesn't Solid have one yet? I'm tired of configuring SSR by myself. Well, I believe it was in 2021 as well, Vite 2.0 came out. And during that same week, Ryan Carniato, the creator of Solid, started working on SolidStart. And the title of this talk is SolidStart, the shape of frameworks to come, and we'll hopefully see why in a bit. Let me just introduce myself real quickly. I'm Daniel Afonso. I'm a developer advocate at OilX. I'm an AGED.io instructor. Like Attila, I'm part of the SolidJS DX team, so I might be a bit biased when I talk about this stuff, but I obviously talk about it because I really love it. You can find me on X, any social media, pretty much anywhere with the handle Daniel JC Afonso. And some other stuff about myself. Last year, I released a book called State Management with React Query. And also last year released an introduction to React testing library on AGED. And I've been maintaining a monthly newsletter called This Month in Solid, where I compile everything that I found online that shows up about Solid. We have core updates, we have ecosystem updates, we have interesting tweets, interesting stuff people showcase. This last month, we had one of the keynote topics of this month in Solid was Solid Hack. So Attila already mentioned it. I'll mention it as well. We are starting Solid Hack back again in October. It's going to be very exciting thanks to our sponsors, which are Netlify and Sentry. We have around $15K, so $15,000 to give away in prizes. So if you want to participate, you can check hack.solidjs.com. Unfortunately, Attila and I cannot participate, which I would really much love to, but we are here to help you. So if you want to participate, feel free to join Solid's Discord as well, and you can ask questions there. You can, if you don't have a group but would like to have a group, you can make groups there. This actually happened yesterday. Someone was like, oh, I have this idea, but I don't have anyone to pair it. You can do that if you join our Discord. So give it a shot. We're really excited to see what everyone's going to build in Solid Hack. Now, one question that a lot of people ask is, why do we need a meta framework? And by the way, I forgot to say, but meta frameworks is usually, it means a framework built on top of a framework. Now, someone is going to say, oh, but these things are not frameworks, they are libraries. Yeah, let's just go with the framework discussion here to make it easier for all of us. But meta frameworks are not just about the rendering modes. It's not just about the proper guidelines, the improved developer experience, or the deployment adapters. It's about being opinionated, and it's about having a faster time to production. When we are developing, when we are building our stuff, that's what we want. We want to ship stuff to production as fast as possible with the most quality as we can. That's why we're getting paid. At least, that's why I'm getting paid. But meta frameworks, and there's one key word here that seems to trigger a couple of people, which is opinionated. Because in the JavaScript world, at least in the JavaScript communities I've been growing up, this is what people think. People start thinking, oh, it's opinionated, means I don't have freedom, means I cannot switch stuff up, means I cannot take stuff apart and build it back again, means I cannot use this library that came out 2 weeks ago and I'm really excited to try out. And this is usually associated with frameworks and with meta frameworks. In a meta framework, they are typically built on this, and which are basically, these are the 4 pillars of meta framework. So we have a router, we have the framework, we have a bundler, and we have the server runtime. And the more up you get, the most opinionated it's going to be. So these are the things that people, when they see, okay, yeah, there's a router, this is probably going to be the thing that's the most opinionated in my meta framework. For instance, 2 years ago, whoa, it's been 2 years ago, a meta framework from an ecosystem changed their router. They introduced a new router in a new version. And everyone lost their minds because they go like, oh, I'm used to this router, I don't want to try a new one. Someone really excited because like, oh, wow, cool new stuff, but now this stuff is locked in, I cannot change, I cannot use another stuff. And this will be relevant to what I'm going to tell you after, because I want to bring back the question that I asked in the introduction, which is, what about Solid? Where's Solid Meta Framework? Well, this year, in May, actually, we released 1.0 of SolidStart. Everyone was waiting for it. It might take a while, have taken a while. So we started building it in 2021, so we released it in 2024. We had actually 2 beta phases, some major rewrites throughout the process. It's because we wanted to build something that we were proud of, and we wanted to build something that could help us say that SolidStart was the shape of frameworks to come. Because, and this is not an inspirational quote, even though it could apply, you choose your own path to your life, but this is basically what you could think about SolidStart. Because SolidStart is, first of all, a starter. It's a way for you to start your journey. And at any point, you can take a left turn. At any point, you can take a right turn. You don't need to get stuck with what you have. And for instance, one of the things that why we say this, You don't need to use Solid Router to have SolidStart. You don't need to use Solid libraries to use it. You can bring your own router. As long as the router is able to talk with SolidStart, which is basically just a JSON representation, it can spit that out. As long as your router can do that, you can bring 10-stack router, for instances, when it supports it. Right now, Solid Router is the only one that's actively supporting it, but you can bake your own stuff. You don't have to be constrained to an opinionated approach. You have the freedom to choose your own journey. And this is one of the things why we say SolidStart is the shape of frameworks to come. It's having something that it's a way for you to start. It can be opinionated if you want, but it doesn't have to. You make your own journey while doing these things. You don't need to pay the price for the features you don't need to, you don't want to use in a sense. Now, these are the things that could come, that are responsible for having a SolidStart application. Like I told you, Solid Router is not mandatory. You can bake that off. The other things kind of are, even though you can try to change them. I've heard some people say they wanted to try taking Nitro out and put some other stuff. If you want to try that out, just check on Solid Discord and try to start that discussion. We'll see if we can help you. But these are the building blocks of a SolidStart application. Even though Solid Router is optional, you don't need it to start with it. Let's assume it's not there. But we have Cerevel, which is our serializer, which we had to bake on purpose from scratch to do what it allows us to do. I won't be talking about Cerevel right now, but Attila also has a very good talk about it and has a cool demo to show it eventually. So if you want, you can talk with him about that. We have the framework, which is Solid. Then we have Vinci, which is basically a wrapper over Vite and Nitro. So Vite is the bundler, and Nitro is our server runtime. The reason we went with Nitro, for instance, is it's because it's powerful enough to power Next, it's powerful enough to power Analog, and if I learned one thing about the Solid community is we like to grow and from learning with each other, we like to help each other, and we like to grow as a community. And by being part of the Nitro community, in a sense, we are contributing to making the ecosystem better. If we find an issue, and that issue is fixed, it will affect people from Next. If people from Analog find an issue and it's fixed, it will help us. So we are all growing together, per se. So Vinci, it's just basically a thin layer built on top of these things to piece them together and help do some extra stuff that we need in Solid. Start. Okay. But let's not go into implementation details. Let's talk about the features, because that's why you're here. You want to see, how do I build a SolidStart application? I want to see how this stuff works. Well, SolidStart has a bunch of features, has a bunch of functionalities. Some of these are familiar to you. Some of these you've seen in different meta frameworks and in different environments. Some are the first time you're probably seeing it. One of them might be single flight mutations, which is possibly one of my favorite ones. I will talk about it in a bit, and I'll show you some cool demos about it. So let's go into coding mode. So I have 22 minutes, plenty enough time to show you 2 demos I have. Okay, so the people in the back, can you see this thing? Just give me a thumbs up. Yes, cool, thank you. So this app, it's called the Cars app, and it's basically a very simple application where you can add a car. So, and by the way, I don't know anything about cars, so if the brand or the name, a model I write doesn't exist, please don't get mad at me. So let's say you want a BMW with a model X1. I have no idea if this exists, but let's do it. The price is going to be something, I don't know, let's put 900 zeros. There's a bunch of information. So this is the information about my cool car. So if I create the car, it's added, I can click on it, and I'm going to see its information. And this is basically the app that we're building and the app that we are showcasing SolidStart features. Let's start in the art of this application, which is our app config. So this is basically our Vinci configuration. And we are doing something here to start, which is we're turning SSR off. So we are starting with a single page application. And that's important for reasons we'll see in a bit. But this defined config, it's like I said, Vinci is a layer on top of Nitro. It's a layer on top of Vite. So if you want, you can pass your Vite customizations there. You can pass some middlewares. You can do whatever you want here. This is highly customizable. So let's get this out of the way. The next point that we have here, let's review the project. It's our entry server, which is basically the entry point when we're starting from the server. Our entry client, which is basically the entry point when we're starting from a client perspective. And then we have our app. Before we go into our app, let me just show you real quick what's here. So in the lib folder, we have our database, which is basically just on storage. So it's just a local storage in this case for us to host our data. So we start by populating and initiating the data. And then in the cars.ts, and there's already some spoilers here, but we'll go over them. We have a get cars functions to get the list of cars, a get car functions to get our individual car, and an add car to add our cars. So going back to our app.ts. So the first thing we see here is our router. So we are using Solid Router here. And inside our router, we have something that's called file routes. So this component enables file routing in SolidStart. What's file routing? Well, file routing, besides telling your application that you don't want to customize or create your routes by hand. So traditionally, you would come here and it'll say, okay, route, this route's going to lead this component, and this component is going to go to this path. When you have file routing, it basically tells your app, okay, look into our folder structure. If there's a routes folder, you're going to basically turn these routes, these components into routes. So when we have the new component, it's basically going to link to the new page. So it's going to be /new. And sorry about going from black and white for the people in the front row. And there's a lot of linking there. When we have index, basically it says, okay, when you get to the /route, that's your index. And then we have a folder called cars. And inside of the folder called cars, we have this thing which has square brackets and something called ID inside of it. This is telling the file routing, okay, when you go to /cars/ID, it's going to go to this route. Why is that ID between square brackets? This is what's called a dynamic route. This means that anytime someone goes to cars/ID, that ID, this one here, it's going to be grabbed. So in this case, if I come here, there's the one. This value is going to be grabbed, and it's going to be passed into our component. And then you can use it for specific reasons. In this case, the specific reason is to fetch the data for only this individual user, and this saves you the time of writing this for a bunch of people. And this is what's called dynamic routing. But file system routing is not just about this. This stuff is pretty cool indeed. It saves, at least I'm a huge fan of file routing and nested routing itself. But it's also about optimizations. Because one thing that I've seen myself do when I was not using file system routing is, okay, I had to write all those routes myself. But then I started to thinking, oh, we need to tree shake our bundle. There's a lot of stuff being loaded. So probably I want to make sure my components are always loaded, which means only being loaded when they are needed. And now wait, this is not the right demo. This is the demo I was showing. For some reason, I went back here. Yeah, so I had to configure lazy loading as well by myself. And as you might be imagining, this file would keep growing and growing and growing and growing. For instance, as file system routing does lazy loading by default for you. It figures out, okay, this route is not going to be needed, so let's lazy load it, let's tree shake our bundle. And there's this is just one of the optimizations we get from file system routing. The way this works is basically whenever we are in that route, route itself, which means that component, it's going to be passed as a children, so props.children, and we're going to render it inside of a suspense layer. So this layer is basically just here to wait until we have our applications to show, and while it's waiting, we have a loading spinner, which is not a spinner, but a loading state. Let's look at our routes, because that's the cool thing now. Our index route is a point to start. So there's something here already which is pretty cool, and I really like, which is called preloading. So what we're doing here is we're telling SolidStart, hey, whenever you hit this route, or you're thinking about loading this route, because remember, when you're hovering over links, there's intents that show up, and you're most likely to click that link. So when you detect stuff like over between a link, or thinking, oh, this route is going to need this data, you can add a preloader there, and this is going to tell you, okay, this route has the dependency and is this data. And why is this cool? It's cool because it's either going to load this data before you come into this route, or it's going to load this data in parallel when you come into this route. And this means that whenever you get to this create async, which is basically your primitive to turn promises into signals, this data is already going to be there, which is really, really, really exciting. And the reason why this is going to happen is thanks to another primitive, another thing that we have inside of these getCars, which is a cache layer. This cache layer basically works in pair with Cerevel, and it's with our router, and it basically is responsible for, okay, if this data is preloaded, we're going to cache it, so that whenever there's another request that comes from the create async, this data already is there. By default, this is going to be a very short-lived cache, so it's not as, the syntax is very similar to if you have used end-stack query before, so some people might think it's very similar. It is, the same way that it has a cache and it has a query cache down there, the query key, I mean, which is cars. What's going to happen here is when this data is fetched, it's cached under cars for a couple of seconds or for a couple of minutes, depending on if you're doing back and forth navigation with the browser. But the gist here is this data is fetched and cached under cars. So that means that whenever this preload happens and this create async calls it, there's not duplicated requests. The data is already there and it's served back. The rest here is pretty much just straightforward solid code. We loop over each car to show that list that we have there. Going into our ID component, the same similar process, but we're just getting an individual car. And this is where dynamic routing is pretty cool, because remember I told you that number, that ID that we've seen before, is going to be injected into the parameters of this route. So this means that whenever I want to say, okay, I want to get the data for the ID 1, which is the one that's going to be there, we just have to say, okay, parameters.id, and we have that stuff. And this is also cached. It's also cached, but now you might be thinking, wait, this query key is just, this cache key is just car. Does it mean that if I go to ID 1, then I go to ID 2 immediately, it's all going to be cached under the same cache? Nope, because there's a number here, this ID, and basically the cache key, it's a serialized reference which mixes this string plus the ID. So it's not, if you have a parameter here, it's going to be used in helping your setting your cache key. This ID, and I'm going to the other application already, that's a spoiler. This ID does basically the same thing we had before. The only difference is we have a stuff here just to make sure we don't render stuff until we have the car. We could have used the first stream for create async. It's patterns you can use however you like. But there's also something really exciting here that some of you might be thinking, what the heck is this thing called useServer? Well, useServer, it's a directive for your bundler. And it's there to tell your bundler, hey, when you're going over this application and you see useServer, you're going to grab the code that it's inside it and send it to the server. What happens is, for instance, as now we're in a single page application. What's going to happen is whenever this function is executed, there's an RPC call from the client to the server. The function executes on the server and sends back the response. If we're running in a server we're running in our server side, the function just executes there and gets the data. And this is the power of useServer. It's basically saying, okay, this stuff doesn't need to be polluting my client. I just want this stuff to be on the server, and this is pretty cool because, well, you have this layer of isolation with these functions. And it's going to enable something really cool, which is single flight mutations. But I'm getting a bit ahead of myself. The other stuff we had in this pretty simple application is a form. Forms are the staples of mutations on the web for years. Sometimes people are used to doing onSubmit and adding a bunch of JavaScript. I just have this standard form, and inside we have this action, which is called addCar. And basically actions, and let's go to this addCar function, and we know it's an action because it says action. Actions are basically just saying, okay, these are functions that are responsible for mutating data. They pair pretty well with cache functions. And as you can see, this is also a server function because we have the useServer directive. And what this action does, and this, I want you to pay attention to this part. First, we get the data from the form data. So there's no need for form state management. You get the form data here. If you want to manage stuff, you can manage it here. If you want to throw errors, you can throw it from here, whatever. Then what we do is we add the data to our storage, and then we return redirect to our index. So basically what we do is whenever we add something, we go back to the index page as we saw earlier. Now, this thing is enabled by the router. And when you have a router that knows all your data dependencies, because we have preload, and it knows exactly where it is and where it needs to be, you can do something really cool, which is called single flight mutations. So before I go to the application, I just want you to visualize something with me. Let's imagine we're submitting a form and we are redirecting traditionally in our application. Let's think about the path. So we do a submit, we do the post of our form. So the post goes to our server. Okay, the data is inserted, and then the post returns a response, typically. And that response is going to be, okay, created, cool. What happens after, traditionally, is we say, okay, now we need to go to the other page because we don't want to stay on this one. So we do a navigation. So we go to our index page for instances. And then we get to that index page, and then we think, oh, wait, now we need our data. So we have to fetch our data. And as you might have noticed, these are procedures, these are steps. So we need to the post, the redirect, and the data fetching. And the same way this happens, this traditionally also happens to your applications. And you're having waterfalls. So if you open your network tab, you're going to see request, request, request. Okay? Everyone following so far? Okay, I see some people nodding. Keep this in mind for what I'm about to show you now. So let's go into our application. Let's just refresh this. It's still working. No, I kill. Let me restart it. Okay. Let's check our network. Gonna add a new car. So we're on this cloud. There's no fetch request here right now. And let's create another car. So let's put again BMW. Oh, this is getting slow. Okay, now we're gonna do X2. The price is gonna be 89999, I don't know. This is stuff. For instance, there's validations, which means I cannot add. Because you can add form validations on your form, you don't need a library to do that. Did you know? It's really exciting. Okay, so there's the forms validation. So this is something we're gonna show. I love it. Okay, so now look at the network tab. Remember, we're expecting, or we traditionally see 3 requests. Let's hope it works. There is only 1. What do you mean? There's only a post here. What? What is this thing? Why is there only 1 request in our application? Well, this is one of my favorite features of SolidStart. It's single flight mutations. And this is the power of having a router that knows all your data dependencies and knows where it is and where it's supposed to be. What's happening here is, when we do a post, the post goes to the server. And the server does the post. But then the server sees, oh, I need to go to this other page, which is the index. And what the server does, it returns that page immediately. But the server also knows, the router also knows, oh, this page needs this data. So it starts fetching this data on the background and streams it in when it's available, all in one flight. So there's only 1 request that happens here. And this is like, for this example, it might sound okay, yeah, but we're going to see a demo next. We have 6 minutes. We're going to see a demo next where this is taken to the extreme, and it allows you even to do some more exciting stuff. So just to finish this demo here, oh, and something that's happening, just so you can see, when I there's the prefetch, remember, there's an intent here. So if I click here, the data, it's already there. That's basically just some of the stuff we have on preload. But this is a Meta framework demo, so let's disable JavaScript, shall we? Disable JavaScript. Oh, and now we don't have an application. What's happening? Can anyone guess? We're still doing client-side rendering. This is still a single-page application. We have been running stuff from the server. We've been doing all these examples so far without in what we had before. So let's revert this back to server-side rendering, which is basically the default mode for SolidStart. Now we have SSR, and it should reload. And everything basically still works. And JavaScript is still disabled, so I can enable it. JavaScript should be there to do progressive enhancement, to enhance your experience. It shouldn't be there to control it. And this is also one of the perks that we got from starting to do server-side rendering and starting to think about how we handle JavaScript on the web. Now, enough showing this demo because I already shown you some cool features, but now you might be thinking, okay, does this scale? And now I have another demo to show you. Let me just go back to still on localhost. Let me kill this one because, and we're not going to need this anymore, so let's close it. Don't save. Let's run this thing. Okay, so this was released yesterday. So if you follow SolidJS or Ryan Carniato, creator of Solid on Twitter, you've probably seen him talk about this because he did a 6-minute video. And I have internet, which is pretty cool. This is Trello, which is basically a demo of Trello. So if anyone has used Trello, you should be familiar how it works. We built this in SolidStart, and let's just see an example. Let me see, I need internet for this to actually work, because I'm doing data fetching to a server. Let's see if we have internet first. It should be connected. Failed to fetch. Wow. Oh, I killed the app because of taking time. Well, that's what happens with live demos. So let's see again. Connect to the internet. Sorry, let's just double check if the internet is working here. Let's get our app back. Let's see. Dun, 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 dun. Okay, we have internet. Cool. Trello, it's basically a clone of Trello. But this thing is taking SolidStart to the limit, and it's taking it fine-grained reactivity to the extreme. Let's just see how this app works firstly. So we can add columns. Column 4. Inside of each column, we can add a car. So we have the third car, so we can add a fourth card. For each card, it can be moved another place, and it can be deleted. This is all powered by SolidStart and signals, but now you might be thinking, okay, what's the exciting thing about here? Well, if you know something about signals, is this stuff is pretty cool, and it's all about optimizing the DOM. And what means, and the cool thing is, when you apply changes to one of these cards, first of all, it's only going to apply to that specific card. There's no re-rendering of all the other crap and all the other stuff. That doesn't happen here. So when you apply changes, it only applies on that part. But there's going to be something more interesting here, and now I'm going to try to show you just some things in the 3 minutes that I have. This is a very big application, so you can check, if you want, you can go to Solid Community /Trello on GitHub, or you just go to Twitter, X, whatever you want to call it, and you have the link there that Ryan shared yesterday. And I'm just going to show you 2 things. This app has some cool examples. First of all, it's the first, one of the first, not one of the first, it's one of the examples of doing protected routes. So there's authentication here. And the way we do authentication is basically, we have a session, we use Vinci to have a session that we can have. We authenticate our users. Our users are created in a database, and then we can log in or register. And for each route, and then I'm just going to show you this example. Let's see where it is, sorry. For each route, we can make sure, okay, before I fetch anything, let's just make sure if I'm authenticated. If I'm not authenticated, you are redirected back. And this is a way you can protect your routes and you can protect your data. And just a very small demo of authentication, which is something some people have been asking to see with SolidStart. So here it is. But this is not the exciting thing about this demo. And bear with me because this part can be a bit complicated to explain, but I'm going to try to do my best. This board, which is that entire board that we've seen, it's basically a huge object in a sense. And that huge object, it's fetched from a server and then stored on a store. So you can use stores when you want something bigger than just signals. You can use it like to store objects. That's basically what we're doing here. And what this thing is doing, first of all, it's doing something which is called optimistic updates. I don't know if you noticed, but I'm going to try to pause network, if the network is still working. I'm going to try to slow it down a bit. No, slow 3G. I don't know if you noticed, but as I move a card, it moves it immediately, and the request hasn't finished. This is what's called optimistic updates. You start doing update before something else. Now, something that you might have noticed already is there is only one request. There's no post and get again. We are doing single flight mutations. We're basically taking single flight to this stuff. Basically, every action that happens here. So we have a move action, there's one request. We have create, which is only one request. If I move again, there's another request. If I delete again, there's another request. And there's only one. There's no post and get. Single flight handles all this stuff for you. And the pretty cool thing about this is this is just an object. So you might be thinking, okay, you do the request, you update the data, then we are doing some stuff here, which is basically, and then I'm going to show you the optimistic phase, which is here. Where is it? Basically, every time we notice there's a mutation, we apply the mutations to our store. So basically, we optimistically update, and we are optimistic that our data will change, so we update our store. And I might be thinking, okay, you do the post, you update our data. This is already pretty cool because it only changes on the specific place it needs to change. But once the fetch comes back, what happens? Do you rebuild the entire tree again? So you just got a new source of data, you just got a new object. You just rebuild the entire thing? No, and this is the power of signals. This is the power of using something that we have here. And I'm going to show it to you. Where is it? Which is produce from stores. Basically, what we are doing is whenever we get the data from the server, what we're going to do is basically check with what we have now on the client, but then it's going to figure out, wait, this is exactly the same object. This is exactly the same thing. So what happens is our UI doesn't need to do a single thing. It's all like this. I don't know if I'm sharing how much I love this enough, but as someone who has built this app in different applications, and I had seen, okay, we get the data, now we have to re-render the entire thing and make sure everything is on the same place. Just getting the data and figuring out, oh, this doesn't need to change. Like, it's really mind-blowing. I don't have more time to explain this app. I'm sorry. If you want, I'll be here all day, and you can ask me questions, we can talk about it. Just want to say some final things. Let me just go back to my slides real quickly. So, SolidStart has its own sandworm now. It has its own, this thing is in the front, it's annoying me. Wait, okay. It has its own meta framework. And like I said in the beginning, SolidStart is a starter. It's a way for you to start your application. You build your own path, you do your own things, and now you can finally build production-ready Solid applications, deploy them, use them anywhere, and personally, for me, it's really exciting. So, like I said, I'll be here all day. I also have stickers, so if you want to ask stickers to Attila, you can ask stickers to Attila. If you want to ask stickers from me, you can ask stickers from me. I'll be here all day. It was a huge pleasure. Thank you so much for having me.